Yo, what's up, everyone? Good morning. And here we are with the last video before Christmas break. Woo! And the gist is that this is going to cover everything that could be on the test. It's only going to be one review sheet, and then I'm going to give you an optional extra credit practice test that we'll go over during the live session. So this video is going to be really long. I'm probably going to split it up into two videos so it uploads quicker. But the four questions that we see kind of cover the four big topics we've learned, the four kind of graphical displays, and the test will also be four questions. Each of the questions won't be like as long as these review questions because some of these are like ridiculously long because I'm covering like everything that could be on the test. But know that everything here you are expected to understand. So yeah, I'm going to go over all of these. It's going to take a while. I'm dialed in to teach for the next hour maybe. But then I'm also looking forward to the live session. I haven't even decided exactly what we're going to do other than talk about the practice test, and I'm going to get your feedback about the class, but then also what you're struggling with. So when you come to the live session, make sure you're kind of ready to ask me questions. But that's all that. Not the best intro, but I'm fine. I'm mostly just want to focus on teaching this stuff. So first, know that in the very back, there is a formula sheet. This will be given to you on the test, but if you don't find the formulas useful, you don't need the formulas in this unit as long as you understand why you add, why you multiply, et cetera, et cetera. But the formula sheet's a reference you have for this test and also a reference on the AP exam. So if that helps you, you can use it. But the other big two things to worry about before we even start are making sure that you can master the notation, so the weird symbols we see, and then also make sure you master like the two big vocabulary words, which are mutually exclusive and independent. Because in this class, there's not that many vocabulary words. There's not that many different concepts you have to know. So whatever they are, make sure you kind of master them. So we're going to really focus on the notation and then mutually exclusive and independent events. But yeah, let's just get into it. It says a survey of 200 Pinole Middle School students was conducted asking what students' dream cars were, and the results were organized in the two-way table below. So we have 3 grade levels and then 4 types of cars. And we know that the two-way table organizes it in detail and says we are this grade and also this kind of car. The totals are useful because they're going to be kind of the bottom of the fraction. And it's also good to know that there's 200 total. And then once we get into the notation, it's also important to know what the names of the events are, okay? Before we do that, we're going to start with what we did with two-way tables before we learn this whole unit. So all A says is what percent of all students prefer the Aston Martin? And anytime you have to find a percent, a probability, a proportion, it's just a fraction where the bottom is the total you're talking about, and then the top is whatever satisfies that condition. So if we're talking about all students, make sure you're dividing by 200, right? And this is a layup, we're just getting warmed up. But out of the 200 students, what number prefer the Aston Martin? And we have the individual grades, but we want to look at this total. And we can just think that 65 out of the 200 students prefer the Aston Martin. So what's that percent, like 32.5? And that would be our first answer. We want to compare that to B, where it says, given that a student is in 8th grade, what is the probability that their favorite car is the Lamborghini? And we know that this phrase given is common in this unit, and that always affects the bottom of the fraction. So if it doesn't tell you any given information or say out of these students, you're going to divide by the total. But it says given that a student is in 8th grade, meaning we're going to ignore the 6th graders and the 7th graders and just talk about the 8th graders, right? Those 75 students. I'm trying to figure out how to, it's like very early in the morning. I think that's okay. So yeah, we're looking at this total. Out of those 75 students, what probability that the favorite car is the Lamborghini. So out of these 75, 5 out of the 75 prefer the Lamborghini. So that's going to be that, which is 6%. And I guess something to say is that I sometimes talk about the final answer pretty quickly, and we always put it in decimal, but you have to know what the decimal means, right? So if you have a decimal, to talk about it as a percent, you just move it over 2, right? So this is 0.325, but hopefully you know that that means 32.5%. This is 0.06, so 6.66%. Good. So you probably could have done those first two without the class. Now we're going to get into the hardest part, which I think is the notation. And we'll start with something very easy, which just says P of A. And all that means is what's the probability of event A. And event A is 6th grade. So all that means is what's the probability that a student is in 6th grade. Okay, we're talking about the totals. So 65 out of my 200 students are in 6th grade. So it's going to be 65 divided by 200. And for all of these, the bottom is going to be 200 until we talk about a given situation, which we know is done with a line. Okay, so that should be pretty easy. It's accidentally the same thing we already did as 0.325. But that means that 32% of my students are in 6th grade. Next, we have the probability of B hill D. And the hill stands for intersection or and, okay? So I think a very valid strategy is to just write out what it means. It means B and D. So if I know that B is 8th grade and D is Tesla, the intersection is where those two rows intersect, literally, right? These 15 students are in 8th grade and they prefer Tesla. So all you have to remember is the hill stands for and, or intersection, and you have to find the intersection of those two rows in a two-way table. So 15 out of my 200 students, or 7.5%, are both. So again, not too difficult. You just have to remember what this means. And what's particularly hard is you have to remember what this means compared to the U. So what E says is the probability of BUC, and the U stands for union or, okay? And it stands for and or because we know that it could be B or C, or it could be both. Okay, so the union adds up anything that is at least one of these two things. So we can actually shade here to make it easier. We're talking about B or C. So if B is 8th grade, again, that's those students. C is Aston Martin, which are those students, right? And we're gonna make Venn diagrams, and hopefully you can even see the Venn diagram here, like in your head. B or C stands for these or these. Now, the formula involves and in your head, all you'd have to do is like literally add up these boxes. But something that could complicate you is you have to make sure you don't double count the 35 in the middle, right? So you could do 75 plus 65 and you'd get 140, but that would be wrong because that would be double counting this 35, which is part of the 65 and part of the 75. So if you're going to use the formula, you always subtract away the intersection. So and is both, but if you have to do or, and you don't want to just add up the boxes, like think it's like a really big table or something, you just subtract away the and or the intersection. So 65 plus 75 minus 35 over 200, or 105 out of 200, which is 0.525. So it's 105. And again, if you wanted to do it with just the table, you could do 55 plus 20 plus 35 plus 15 plus 10 plus 20, and you get the same result. Okay, so hopefully that makes sense to everyone. And the key is to understand the difference between hill, the and U, the intersection. LOL. I don't know what I wanted to put here, so we will skip F because we're going to cover everything else. The next thing you could see is probability of an event with a C on top, and that C stands for complement, which means not D, okay? So the probability of D is the probability that a student likes a Tesla, which is only 25 of my students, right? So the probability of D is like 25 out of 200. So think that the probability of the complement of D is every other student. So in my survey, 175 of the students chose a different car, right? The Tesla wasn't that popular. So these numbers all added up. So complement just means not that probability. And you could find this probability as like 12%, or you could just do the second one, which is 87%. So that's that. And then let's do this final one. The final notation could be this, and it says find the probability of C line A. And for this, I'm going to write it out. And the line means given. And all that means is what's the probability of C, which is that the student likes an Aston Martin, given or assuming that they're in 6th grade, okay? So this is going to be the only question in this whole set where the bottom of the fraction isn't 200. If you see given, that means we're no longer talking about all the students. So the bottom is going to be 65, right? And this is going to be very similar to B, just written in notation. It's saying given a student's in 6th grade. So assuming we're one of these 65 students, what's the probability we like the Aston Martin, which is 10 out of those 65 students. A note on rounding, like 3 is always good in my opinion, 3 numbers after the decimal. But if you go further, and if you just do 2, like I don't really care that much. So that's that. And now we're going to talk about the 2 big vocabulary words, which are independence and mutually exclusive. And to me, the hardest part is that they sound really similar and they can be really easily confused. First, it just says, is liking Tesla independent of grade level? Why or why not? And all this would mean is that it doesn't matter what grade you're in. If you're a 6th grader, a 7th grader, an 8th grader, you like the Tesla at the same rate. And if we're going to do that, and if you ever want to test independence, all you have to do is find the different probabilities of your subsections and see whether or not they're equal. So what I mean by that is we're talking about Teslas. If you're a 6th grader, there's a 0% chance, so 0 out of 65, that you like Teslas, right? But if you're in 7th grade, the probability changes because 10 out of the 67th graders like Teslas. So already we know it's not independent, and hopefully you can see that, because independent would mean that all of these percentages are the exact same. It doesn't matter what grade you're in, you prefer Teslas at the same rate. So the last one is 15 out of 75. And because these probabilities are all different, we know that it's not independent. And we're going to keep talking about independence based on different graphs. So that's just the start of that. But hopefully that makes sense to everyone logically, right? 8th graders like them the most. And if you were to randomly pick an 8th grader, or if you have an 8th grade in front of you, the chances are they like Teslas more than if they were in 7th grade. Now we're gonna, this is the longest question of all time, but we're gonna draw some Venn diagrams based on this 2-way table. So we're gonna transition into the second type of graph, which is the Venn diagram. And all you have to think about the Venn diagram, I don't even know why I did that. All you have to think about the Venn diagram is it's a really good way to organize 2 events. This 2-way table tells us a ton of information. right? And you can actually come up with a bunch of different events within the two-way table. But if you ever want to compare two events and see if there's an intersection between them or anything like that, you can take two events from the entire two-way table and make a diagram with them. So what I mean by that is it's saying we want to draw a Venn diagram for A and C. So the Venn diagram always has two circles. And we can say that A is the first circle, or sixth grade, and C is the second circle, which is the Ashton Martin, right? All we would have to do is put in the sixth graders here and the Ashton Martins here. But we know that the best way to do a Venn diagram is start in the middle. And the reason is, like, we see that there's 65 students who are in sixth grade, but we don't put 65 here, right? Because we have to put the intersection first. So all I'm looking for is very similar to the ones we've already done. We've already found intersection questions. The intersection of A and C is 10. 10 students are in sixth grade and like the Ashton Martin. Then there's 55 students who are in sixth grade that don't like the Ashton Martin, right? They like the Porsche or the Lamborghini. Then here it's also going to be 55 because it's these students that like the Ashton Martin but aren't in sixth grade, right? So that's my Venn diagram. And then on the outside, we can put every other student. So all we have to do is add them up. We have 65 plus 55, 120. There's 80 students who aren't part of either of these things, right? So that's my Venn diagram. And it asks us whether the events are mutually exclusive or not. But we're going to skip that and do these two together. So for K, we're also going to draw a Venn diagram with A and D. So let me just set that up. So this is sixth grade in Tesla, and the intersection here is 0, and that's going to be the big gist of this whole thing. Hopefully you noticed that. But there's no sixth graders who like the Tesla. So the intersection is 0. There's 65 students who are in one of these other sections. And then in Tesla, there are these 25 7th and 8th graders who like the Tesla. My idea is like the Tesla is like a mature choice. Like a sixth grader is not going to choose the Tesla, but an eighth grader might, be more environmentally conscious or something like that. So yeah, hopefully that makes sense. And then we could put the outside at 110. And all we have to do now is talk about whether the events are mutually exclusive. And all mutually exclusive means is that you can't be both at the same time. Okay. So first K, it is mutually exclusive. And that's just because there's no intersection between Tesla and sixth grade. So if you were to be mutually exclusive in a two-way table, one of your values has to be 0, okay? Because that signals that there's no intersection between the two of them. Anytime there's an intersection, they're not mutually exclusive. So this is much more common. But hopefully that makes sense, and I think it's pretty obvious. You can still make your Venn diagram like this with a 0 in the middle. But if it helps you visualize, you could do something like that. And I know I did that really quick and ugly, but there's no intersection. So you could say this is 6th, this is the Tesla, and there's no intersection between them. Okay, that was the longest question of all time, but we're gonna move on. And that's why I'm splitting the video up in a few, but I think none of the questions will be as tedious. This one is going to be very similar to the first. We're trying to figure out some notation, but it's going to be based on a word problem without the diagram at first. And all we have to do is draw a Venn diagram. So we've already done this for a few, and I think it'll be easy now. But let's read the question. It says, the mayor of Pinole is trying to secure the coronavirus vaccine for members of the town. And how many members of the community are at high risk of infection? And they take a random survey of 150 members of the community and find that 50 are over 65, 90 have underlying health conditions, and 40 had neither. And we know that a person's really high risk if they are both over 65 and health conditions. So anyone that is in this intersection would be a person that should get the vaccine first, but then anyone who's one of these two things is like an important or at-risk person also. So we want to fill this out so that the mayor of Pinole can figure out who to get the vaccine to. And we know that this is 50 and this is 90, but it doesn't tell us how many are both. So in that case, it depends on what else is given, but if it tells you the outside or the neither, that's a really good place to start. So if we know that 40 of the students are neither, that means that this plus this plus this is going to be the other 110 students or citizens. Again, start at the outside or on the inside. So we know that this plus this plus this has to equal 110. The complication and what we do in this situation to figure out exactly what's in the intersection is we add up the two circles without an intersection and then figure out how much needs to be double counted. So what I mean is that if there's 50 people over 65 and 90 people with underlying health conditions, that adds up to 140. But once you put someone in the middle, they're double counted. So it's really easy. All you have to do is 140 minus 110 because we need them to add up to 110 to find the middle. So the middle is going to be 30. So let me just say that again. Without anything in the middle, they add up to 140. But if we want to add them up to 110, because the outside's 40, the inside's 110, we can put 30 in the middle because that reduces both sides by 30. And then the whole thing will add up to 110. So I love that. I think that's beautiful math. Very, very cool. And this is what it means in practice. And hopefully that makes sense. Now it satisfies every condition given to us because it adds up to 150. That's like the hardest a Venn diagram could be. So once we do that, hopefully you feel good. B just says, are the two events mutually exclusive? And once you have the Venn diagram, it's obvious they aren't mutually exclusive because you can be both. And why is, yeah, just answer why on your own. Okay, now let's do some notation with this Venn diagram. And I honestly think this should be really easy considering it's harder in a two-way table in my opinion. But let's just write down everything it says. This is A and B, which is just 30 out of 150, or 20%, I think. This is A or B. And the hardest part is you just add up all of this, right? It could be this or both. So it's 110 out of 150. And then finally, E is what's the probability of B given A. And seriously, write it out, and it's so easy. This one's gonna have a different bottom of the fraction because it's B given A. So all we have to do is figure out the probability of A first. So A in this case is over 65. So out of the 50 people who are over 65, what percent or how many of those people have underlying health conditions? So out of those 50, 30 out of the 50 go here, and that's 0.6. Anytime it's given, think that you're no longer talking about everyone. You're going to reduce it down to a certain part of your diagram. So it's these 50 people, and it's 30 out of 50. And this is probably going to be the hardest question of this set. We have F on the next page, and it says, is having an underlying health condition independent of being over 65? And this is difficult, but all this means is, do people over the age of 65 have health conditions more often than people who aren't over the age of 65? And that's why I think this class it's really important to just understand what it means. Is having an underlying health condition independent of being over 65? So what we have to figure out is how likely someone who's over the age of 65 is to have a health condition. And that shouldn't be too bad, right? Because that's actually just what we did for E, right? So if someone is over 65, they have a 60% chance of having a health condition. But for independence, you always have to compare percentages. And in this case, all we have to compare this to is not over 65. And I think this might be the hardest thing, the Venn diagram independence, because this is a little funky. We know that 60% of people over 65 have a health condition, but how do we find the percent that aren't over 65 that have a health condition? All we have to do is think these 50 people are over 65, and these 100 people are not over the age of 65. So, and I just psyched myself out because I think this is hard. I had to think for 1 second, but there's 100 people who are not 65, right? And these 60 people have a health condition, right? There's 4 numbers in a Venn diagram. This first probability is of the people who are 65, 30 out of 50 have a health condition. But of these 100 people who are under 65, these 60 people, or a lot of people, still have health conditions, right? 60 out of the total 100. Because we know 90 people have a health condition. 30 of them are over 65, but these 60 people are under. And this was accidental, and I'm very happy about it. But this person is also 0.6, right? So we could say that having a health condition is independent, because it doesn't matter if you're over or under 65, you're always going to have a health condition 60% of the time, right? Everyone has a health condition 60% of the time. And I hope that makes sense. All right, that's going to be the end of the first video, but I'm going to keep rolling with the second half.